name's Ian Fennell. I'm a solution architect with Matillion. In this video, I'm going to be discussing the ways in which you can use Matillion to deal with common data quality problems, such as duplicated records, missing values, and also to discuss ways in which you can apply business rules in your transformation logic. Let's get started. I'm going to be using a civil aviation data set in which there's one main table, this table of flights, and we have one record in here for every flight that took place over something like 25 years. And there are columns for the year and the month and the day of the flight, the arrival and departure times, the flight number, the aircraft tail number, and the origin and destination airports. I've loaded this data and we have something like 124 million records in the table now. Once we start to dig into this data in detail, we're very likely to find lots of technical problems and quirks with it. But the main thing to bear in mind as we work through the data quality patterns is that if that data is good enough for the business to run its day-to-day operations on, then it's certainly good enough for us to put into the data warehouse. So our first responsibility is to load it accurately and then report back or audit back any data which we think really does have to be fixed at source. And then also we need to be very certain that we have first of all found and then secondly applied any business rules which we need in order to make very sure that we're reading that data correctly. One of the most common data quality problems, and the first one that we'll look at, is when there's missing data. Now, if there are whole missing records, then there's really not much that we can do about it here as long as we've accurately loaded all of the data that was sent over from source. But we can deal with missing columns or missing values. We can detect that and send a report, an audit report, back to source to hopefully get those fixed. And that's what this job is looking at. So this is a good pattern for a Matillion transformation job to detect and deal with missing values. The pattern is to start with your source data and to first of all use a replicate component, which basically makes two copies of the data that gets sent into it. And then each one of those copies gets sent to a filter. And now these filters need to be equal and opposite to each other so that every record of incoming data only goes through one of the filters. And in this case we can check, we're checking the origin airport of the flights, and the filter at the top has the origin not null or blank, in other words it's present, and the filter at the bottom is exactly opposite to that, and the origin is null or blank. So records that come down here have got a missing origin and will go on to be collected. Records that go through here do have an origin. And in fact, this job has two examples of the same pattern. That data will get sent to another replicate component, which itself has two equal and opposite filters. This time we're looking at the destination airport. Here, the destination is not null or blank. And with this one, exactly opposite, the destination is null or blank. So the idea is that records that come through either of these paths here have either a missing origin or a missing destination. So they're united using this unite component, and a calculator component will add a couple of derived columns for them for the audit log. There's the date of rejection, and then there's the rejection reason, which is just a fixed string. So the idea is that we would take this data and maybe append that into an audit log and send that back to source for correction. In contrast, the data that comes to this point has been through two filters. It definitely both has an origin and a destination airport, which is obviously very important for a record of flight. And we can safely now use this perhaps in a rewrite table operation for input for the next stage of transformations. Another very common data quality problem that we'll move on to now is the case of duplicated data. And that means having multiple records which are supposed to be about the same subject but which seem to contradict each other. A word of warning before starting to delete duplicated records: make very sure that you're reading it correctly. because it might be the case that they're not actually duplicates, but they simply represent the way something has changed over time. You'll recognize in this job exactly the same pattern of components that we saw on the previous one, where there's a replication followed by a pair of complementary filters. Now, these filters are actually on a column which we've derived, and the top filter is where the value is equal to 1, and the bottom filter, equal and opposite, is where that value is not equal to 1. The value has been calculated in the Matillion calculator component here, and we're taking advantage of a windowing or analytic function, the row number function, and that allows us to enumerate within a set of duplicated records. And the things you need to specify first of all are the list of columns that you think should be unique, and we've got 1, 2, 3, 4, 5, 6, 7 columns in the unique key. And then secondly, you need to list a column which can enable Redshift to differentiate between members of the set. So normally you would choose an updated timestamp, perhaps descending here, so it will take the latest value out of every set of duplicates. So the data that comes out through the top filter here is not duplicated, and once again we can use this for downstream transformation. That's the data minus duplicates. In contrast, the data that comes through this filter goes to another calculator component, exactly the same as the one in the previous job. We've added an audit date and a rejection reason to duplicate this time. And these records can get sent back to source, perhaps via an audit table for investigation and probably for correction. In the next example, we'll look at another very common situation where there are data values that are normally very well behaved, very regular, but occasionally perhaps contain outliers or invalid values that can't be handled normally. And it happens very commonly with dates. So using this fixed flow component, I've got a sample of 3 records here to illustrate how to handle this. So there are 3 records. The first one of them we can clearly see is probably a valid date. Now in Australia or the UK, you'd correctly interpret that as the 29th of January. In the US, that would fail because 29 is not a valid month. So that means we need to be very careful with our format masks. The date value tomorrow here, well, as a human, I can interpret that as tomorrow's date. But the nonsense one, in third place here, there's no way to convert that into a date. So we need to be able to deal with all of these 3 cases. And the normal way to do this is to use a calculator containing a case statement. And I'll open this up to show you. So in the first case, where the date comprises 4 digits, dash, 2 digits, dash, 2 digits, then it's got a chance of being a valid date. And we're just careful to convert that using a known format mask. In the second case, where we're using the magic string tomorrow, then that just gets interpreted as today's date plus 1, and anything else will get converted as a null. So the output of this, all 3 rows get converted correctly. The date comes through as a real date this time. Tomorrow gets turned in tomorrow's date, and the nonsense date just comes out as a null. But nevertheless, it still has 3 records, so all of them got processed. We've seen some examples of how to apply some quite simple business rules there, so we'll move on now to one that's a bit more sophisticated and needs to be applied in 2 separate steps. Some of the incoming flight records have got missing distance values, and we need to fill those in so that we can do some downstream analytics using the values. The business rule in this case is that where the distance is missing, we can fill it in by finding the most common distance value among all the flight records between that pair of airports and assume that the distance was equal to that value. The first step in applying the business rule is to find all of those most common distances between pairs of airports, and that's what this job does. Starting with selecting those columns from the flight table, we then filter only records where the origin, the destination and the distance are all present, since they're the only records which are useful for what we're trying to do. We then aggregate those right down to the level of origin, distance and destination and add a count aggregation. At this point, we need to do a trick to make sure that we're considering journeys in both directions. And it's another set of components with a replicate followed by two complementary filters. Now the filter at the top is where origin is less than destination alphabetically, and that data goes straight through. The filter at the bottom is opposite to that, where the origin is greater than the destination. And the data comes out of there and goes through a rename component which just swaps the names of those two columns. So by the time they get reunited through this union all, we're then able to sum the frequencies between pairs of airports, and we're dealing with them in a consistent order. At this point, we may have a few cases where there's been differences over time about exactly how distances have been calculated, and we might have more than one distinct value of a distance between a pair of airports. So we'll use another one of those row number functions, this time inside a rank component, partitioning by the origin and the destination to make sure that we follow the business rule and just take the most commonly encountered distance if there's any disagreement. So in the next step, we can filter on that preference column that we've just added, and we'll take preference 1, which is the most common value from every pair of airports, so that as the last step of the job, when we rewrite the table, which we're going to be using in the second part, we can be confident that there's no duplication. In order to apply this business rule, we would run the job, create the target table, common flight distances, and then use that in the next transformation. Now in this one, we start with the same raw flight data. We then do a left join to the common flight distances 2 ways around through this replicate component. The first of these is a left join where the origin and the destination happen to be in alphabetical order. So it's origin to origin, destination to destination. The second left join is on the same data set, but it's where the ordering happens to be the other way around. So it's origin to destination, destination to origin. And then the last step is to have a calculator component which coalesces those 3 distances: the original one from the flights table, the origin to destination, and the destination to origin distance. And hopefully one of those 3 values at least will have a value. I hope you found that a useful guide as to the ways in which you can start to develop a data quality framework using Matillion ETL for Redshift. For more information, you can go to matillion.com, or you can always launch a 14-day free trial from the marketplace.